Hi, I'm Phil Dooley at JET. We're talking about nuclear fusion. That's the process that powers the sun. Turns out the sun, though, isn't a particularly good fusion reactor. It's fusing hydrogen into helium at a kind of slow rate. It's very big, so it puts out a lot of heat, but we can do better here at Earth. So what we need is some fuel, hydrogen, types of hydrogen called deuterium and tritium, not too much, and we need to confine that into a tight space. Make sure that these things collide a lot so that we get lots of fusion reactions happening. So we've got our particles, now we need to get them hot. That means making them move fast enough that when they collide, they overcome the repulsion between positive particles, and that means that they'll then be able to get close enough to fuse. So we really need lots of temperature, between 100 and 200 million degrees. The third ingredient to really get this working is time, keeping it all going at once, which is pretty tricky really, as you can see. So the density's got too low. That means there's not enough collisions. The particles need to be dense enough, not too dense, because that then means energy is lost through collisions with electrons. So we've got to get it just right. We've lost time. That means that the particles didn't stay confined long enough for a collision to happen, enough collisions to really get a lot of fusion energy created. So we need to make the confinement last for longer. Let's have another go. So we've lost temperature. If the temperature gets too low, it means the particles aren't moving fast enough to overcome the positive repulsion between the different types of hydrogen. So that means they'll never be able to fuse, even if they do collide. Got to keep the temperature high for a long time. Let's have another go. So the measure of how well we're going at keeping all these three quantities in the air at once, it's called triple product. And that's a vital concept for fusion energy production. Here in JET is just a little bit too low as far as triple product is concerned. The density's fine, that's about 1 million times less than the air we breathe. The temperature is over 100 million degrees, that's fine too, but the particles escape a bit too quickly. The confinement time's not long enough. So the way to fix that is by building a larger reactor. ITER will be 10 times larger than JET by volume, and that will mean that the particles have to travel further before they can escape through the edge of the plasma. So that, we're confident, will be much more efficient than the sun, 2,000 times more efficient than the sun as a fusion reactor. And in fact, it will produce 0.5 gigawatt of power. For the first time on Earth, really commercial scale amounts of fusion power produced.